Hi guys, this is Mr. Cappert. This is part 3 of statics, and this is the end of statics for you guys. We are all done with background research after this. So this problem looks similar to what we did before. You have a 2,000-pound car parked on a truss bridge. Notice it is not in the center, and the bridge itself weighs 100,000 pounds. Draw a free body diagram of the bridge and solve for the support reactions. So the difference between this and what we did before is slight, but it has an effect upon your answer. Notice before we had the car in the exact center. That does make a difference. And what I told you at that time was when we got to this equation for the summation of the forces in the y direction, that to just split the two supports. So 3,000 and then 3,000. But if the car is closer to one side, such as this pin A here, obviously there's going to be more support needed here. It's going to be pressing down harder on this side of the bridge than that side. And you can't just use my trick of, hey, just get this 6,000 and divide it in two. So what you're going to have to do is come up with another equation. So in engineering, anytime you have an unknown, you need an equation to solve for it. If you have two missing values, you need two equations. You have three things that you're trying to find. You need three equations. Four things, you need four equations. So we're going to actually need three equations to solve this. The first thing you're going to do is draw your free body diagram, like I've said before. You have the support A holding the bridge up. You have support E here holding the bridge up, obviously. A 100,000-pound bridge that's acting on the very center of the bridge. And what is different here is the car is at 10 feet from this end. It weighs 2,000 pounds. So make sure you put what the positive directions are. Up is positive for y, to the right is positive for x. And then with our moments, our rotational force, clockwise is considered positive. Now, at the beginning, everything is going to be the same. Sum up your forces in the x direction, set them equal to 0. You have only one force in x direction. This pin holds the bridge from going back and forth. But in this case, there's no wind. There's nothing pushing on the bridge to go to the left and the right. So that is our only force, and it equals 0. It's not needed unless there's some wind. Now, for our forces in the y direction, you want to sum those up like you have before. Negative is down. So 2,000 pounds of the car is going down, negative. The bridge weighs 100,000 pounds. That's negative 100,000 pounds. And we have two supports holding up the bridge, this pin A and roller E. And they're in the y direction going upward, so they're positive. Now, this is the different part here, is we have 1, 2, 3 unknowns, and we have 1, 2 equations. If you have 3 unknowns, you need 3 equations. So our third equation is going to be a summation of the moments about point A. So about this point. So like you guys did before, find the moments. Force times distance. So I'm going to go from left to right to keep this nice and organized. You have 2,000 pounds that's acting 10 feet from point A. Notice summation of moments about A. So it is 10 feet away. So take those two times each other. They are going in a clockwise way. So it is positive. Also, we have 100,000 pounds. It is acting in a positive direction. It is 20 feet away. Force times distance. You have one other force that could cause this bridge to spin, and that's your support EY. It is pressing up, and it would rotate the bridge potentially this way around, counterclockwise, which is negative. So force EY times its distance, it is 40 feet away. All of these equals 0 because the bridge is not spinning. It is stationary. Now this is where things get tricky. And before I tell you about that, there's one other thing. You may be thinking, why am I not doing anything with AY? AY is acting right on the pin, so it would never cause this to spin. You could not spin this bridge by hitting right here. You could not spin it around this pin. So that's why AY doesn't matter. It's 0 feet away. That would be 0. So you don't put it in here. Now this is the tricky part. If you're not this far in algebra, it's fine just to set this up and not solve. I would prefer you solve this, but if you can't, let me know. I can come over and sit with you for a while. You may have not done this before. You first need to use algebra to solve for EY. It's the only variable, unknown variable in this equation. You first find EY. You can now go back to this equation, the summation of the forces in the y direction, and you can plug this value in for EY. You now are left with only AY in this equation. Use algebra to move all of these terms over to the right side, and you get 51,500 pounds. Always make sure that your answer makes sense. So this is pressing down with what? 102,000 pounds total on this. If you add these two supports together, you get 102,000 pounds. Another thing to check is AY is slightly larger than EY. That makes sense because the car is over on that side of the bridge. If it was on this side, it would be different. So with your guys' truss bridges in the competition, you need to have an opening on the bridge where I can put a plate through in order to load it with weight to break your bridge. So you are going to get to decide whether you're going to have a gap right in the middle. With this one, I couldn't do it. The pipe would rest on here. I would have to put the pipe or the plate in this area. So if it's in the exact center, you don't have to do this summation of moments. But if you're going to have me put the plate through on a side or the other side, then you'll have to do this. And that's up to you if you want to do that. Hope this helps. I'm going to be going around. Make sure you ask for my help.